Go back and do a summary of here what we figured out. What we figured out here is this important fact. And you go home and check it on a couple of problems, but it doesn't depend on the 3. If I want the sum from n equals 0 to 4 of 2 to the n, then I claim that's 1 minus 2 to the what? 5th over 1 minus 2. Let's check. This side is 2 to the 0 plus 2 to the 1 plus 2 squared plus 2 cubed plus 2 to the 4th, right? This side is 1 minus 32 over 1 minus 2. This is 16 plus 8 plus 4 plus 2 plus 1. 16, 26, 31. Now,
Where did the 5th come from?
pardon?
Well, you got the numerator 1 minus 2 to the 5th. Where that 5th came from?
My formula here, if I were to write it generically for you, would say this. Whatever you want to add up to, whatever your power is here, it's going to be 1 more than this. Now, there's 2 things to observe that are important here. What if I change this problem? We good on how to apply the formula? Any questions on what I did here? So this is generic. Let R be some real number. Pick any real number. I don't care what number. I use 2 here and 3 here. Doesn't matter what number you plug in. It's a formula. So for any number, real number you pick, if you want to sum from 0 to n of these, n plus 1 of them, right? Starting with 1, which is back to Talbert's question. Starting at 0 gives me the 1 for the first term every time, right? Then this is your formula. What if I had added this up to infinity? What would I have gotten? What if I had gone to infinity? What would it have been? Yeah, you can think of it as infinity plus 1. What's 2 to the infinity? The top's going to be what? Huge and negative, right? And if you look at what the terms are, you're going to add up 2 to the 4th plus 2 to the 5th plus 2. At some point, you're adding 2 to the billion. It's going to be infinity, right? It's not going to converge. So the sum from n equals 0 to infinity of 2 to the n diverges. Why? Because this is too big. This is bigger than 1, so you're adding bigger and bigger and bigger stuff up every time, right? Common sense. Don't need a mathematical proof of that. That's common sense. But what if I did something like the sum from 0 to n of 1 over 2 to the n? That's still a real number, so my formula should still apply. Let's put a 10 up here. It should be 1 minus, no, I can't multiply that well. Let's put a 5 up there. 1 minus 1 over 2 to the 6th over 1 minus 1 over 2. So that's 1 minus 1 over 2 to the 6th over a half. Let's see, 2 to the 6th is 64. 1 minus 1 over 64, all times 2, look and multiply. 63, 64 times 2, 126 over 64. Right, whatever it is, it's a number. Now, what happens to this if I wanted to go to infinity?
Real small.
Yeah, this part's going to be, think of it as to the infinity power, right? That's, wouldn't do it intuitively if I would have enough time, but I don't have enough time. So if I think of 1/2 to the infinity, what's that going to be? 1 over 2 to the infinity, which is 0, right? So that gives us a second very important formula. Because what is the definition of this going to infinity? It's the limit of this as n goes to infinity. But as n goes to infinity, that goes to 0, right? Okay, that gives you two very important formulas. To try to get you success on 276, I'm going to hold you for one more minute and say something. Suppose I wanted the sum from n equals 2 to 4 of 2 to the n. Here's what I would do. I have a formula if it starts at 0, right? I have a formula if it starts at 0. So instead of starting it at 2, start it at 0 so I can use my formula and then subtract off the two terms that aren't in the one that I had over there. So there's a slick trick for when they don't start where you want them to, make them start where you want to and then subtract off the terms. Okay, I'm over. Stay off the streets. I'll see you on